Watch a wave roll across the ocean. Just watch it for a moment. Your eyes tell you something is traveling. Energy is moving. Water is flowing toward the shore. You can see it. The wave rises, crests, crashes on the beach. But here's the startling truth. The wave isn't moving. Not really. Not the way you think. The water isn't traveling across the ocean. Nothing is being transported from one place to another. At least not in the way it appears. What you're seeing is pure illusion. A collective motion that creates the appearance of travel without anything actually going anywhere. And I know that sounds wrong. You're looking at the ocean. The waves are clearly moving. How can I say they're not? But stay with me. Because understanding what's really happening will change how you see everything. From sound to light to the quantum world itself. The best way to understand what a wave really is starts not with water or light, but with people. People in a stadium. You've probably seen it. Thousands of spectators standing up and sitting down in sequence, creating a moving pattern that races around the arena. The wave, they call it. And here's the key question. The question that reveals everything. What's moving? The pattern is moving, yes. You can see it traveling around the stadium. You can time it. You can measure its speed. Maybe it goes around the whole stadium in 15 seconds. But the people? What are the people doing? Each person only moves up and down. In place. No one actually travels around the stadium. No one runs from their seat to chase the pattern. Everyone stays exactly where they are. Standing and sitting. The wave is real. You can see it. You can measure it. You can predict when it will reach a certain section. But it's not a thing. It's a coordinated behavior. A pattern of motion. An organization of energy. And this is exactly what all waves are. Water waves, sound waves, light waves, quantum probability waves. They're all patterns of organized motion in a medium. Or in some cases, and this gets strange, patterns in quantum fields that exist everywhere. But nothing is actually traveling. The medium itself oscillates in place, while the pattern propagates. And this bothers me. It should bother you too. Because the word wave makes it sound like something is moving, flowing, traveling. The language itself tricks us. Look closely at water waves. Really look at them. And you'll discover something surprising. Water molecules don't move forward with the wave. They move in circles. Or, more precisely, in ellipses. As a wave passes through a region of water, each molecule rises, moves slightly forward, falls, moves slightly back, and returns almost to where it started. Almost, but not quite. There is a tiny net forward motion. That's why waves eventually transport some water toward shore. That's why debris floats toward the beach over time. But the vast majority of the motion is circular, oscillating. The wave pattern travels at meters per second, but the water itself barely moves at all. This is why you can float in the ocean and feel waves pass under you without being carried forward rapidly by each wave. You bob up and down, tracing that same circular path, while the wave pattern races past you toward shore. The energy is moving. Yes, the pattern is moving. Information about what's happening upstream is propagating downstream. But the water, the medium itself, is mostly just oscillating in place. This distinction is crucial, and most people miss it entirely. They think the wave is made of water traveling, but it's not. It's made of water oscillating while a pattern of organization travels through it. Now, sound waves are even more abstract, even stranger. When sound travels through air, the air molecules aren't traveling with the wave. They're not flowing from the speaker to your ear. Instead, they're oscillating back and forth, along the direction of the wave's motion. Imagine a line of people standing close together. The person at one end pushes forward, compressing into the person next to them. That person feels the push and compresses into the next, and so on down the line. Then everyone relaxes back to their original position. Maybe they even pull back slightly, creating a rarefaction, a region of lower density. The compression wave, the pattern of increased density, travels down the line. But each person only moved forward and back a tiny amount, maybe a few millimeters. This is sound. Regions of compression followed by regions of rarefaction, propagating through air at 343 meters per second at room temperature. The air molecules themselves? They have an average speed of about 500 meters per second in random directions due to thermal motion. They're zipping around constantly, colliding billions of times per second. But they're not traveling with the sound. They're oscillating, creating regions of slightly higher and lower density that constitute the wave. When someone speaks to you from across a room, no air molecules travel from their mouth to your ear. Not a single molecule makes that journey. The pattern of compressions and rarefactions travels. The wave carries information, the shape of the sound, the voice, the meaning. But the medium itself stays more or less where it is, jiggling back and forth, doing its little dance. And this is weird when you think about it. Information travels without anything carrying it. Pattern moves without substance moving. For centuries, physicists assumed that light, like sound, must require a medium, something to oscillate, something to carry the wave. They called it the luminiferous ether, an invisible substance filling all of space that light waves would ripple through like water waves ripple through water. It made sense. Waves need a medium. That's what a wave is, an oscillation in a medium. So, light must have one. But in 1887, Albert Michelson and Edward Morley did an experiment. A beautiful, precise experiment designed to detect Earth's motion through this ether. If the ether exists, and Earth is moving through it, then light should travel at different speeds depending on direction, like swimming with or against a current. They built an interferometer, split a beam of light, sent it in perpendicular directions, recombined it, and looked for interference patterns that would shift as Earth rotated, and they found nothing. No shift, no difference. Light traveled at the same speed in all directions, regardless of Earth's motion. This was deeply confusing, troubling. If a wave is an oscillation in a medium, and light is a wave, but light has no medium, what's waving? What is it that oscillates when light travels through empty space? The answer came decades later from quantum field theory. From a deeper understanding of what fields are, what we call light is an oscillation in the electromagnetic field, a fundamental field that exists everywhere in space. Not sometimes, not in some places, everywhere, all the time. When charges accelerate, they create disturbances in this field, and those disturbances propagate outward at the speed of light, about 300 million meters per second in vacuum. But even here, nothing is moving. Not in the ordinary sense. The field itself doesn't travel. The field is already there. Every point in space has a field value, an electric field component and a magnetic field component, and that value oscillates as the wave passes. The pattern of oscillation propagates, but the field is everywhere, all the time. It's the configuration of the field that changes, creating the appearance of something traveling. And then photons complicate this picture even further. Because in quantum mechanics, light behaves like both a wave and a particle. But neither description is quite right. This bothers me. It's bothered physicists for a century. What's really happening? What is light at the deepest level? What we can say is this: the electromagnetic field is quantized. It can only carry energy in discrete packets. These packets we call photons. But they're not little balls of light flying through space. They're not particles in the classical sense. They're excitations in the field. Localized disturbances that maintain their identity as they propagate. Quantum wave packets that have some properties of particles and some properties of waves. And honestly, I don't think we fully understand what they are. We have mathematical descriptions that work. We can calculate. We can predict. But what is a photon really? I'm not sure anyone knows. Some of the most beautiful waves don't travel at all. They oscillate in place. We call them standing waves. Standing waves occur when a wave reflects back on itself, creating a pattern that oscillates but doesn't propagate anywhere. Pluck a guitar string. You create a standing wave. The string vibrates, up and down, or side to side. But the pattern doesn't travel along the string. It just oscillates. Certain points on the string, called nodes, don't move at all. They're fixed. Zero amplitude.
Other points, called antinodes, oscillate with maximum amplitude, swinging back and forth wildly, but nothing is going anywhere. The wave exists. It oscillates, but it doesn't travel. And this isn't some special case, some exotic exception. All confined waves, from the sound in a pipe to the electrons in an atom, are standing waves. Think about that. The electron orbits in an atom aren't really orbits. They're not little planets circling a nucleus. They're standing waves in the quantum probability field surrounding the nucleus. The electron doesn't orbit like a planet, moving through space in a trajectory. It exists as a wave pattern wrapped around the atom, oscillating in time but not moving through space in any classical sense. And this is why atoms are stable. This is why electrons don't spiral into the nucleus radiating energy continuously like classical physics predicted they should. The electron can only exist in configurations where its wave pattern fits neatly around the nucleus, where it completes a whole number of wavelengths, where it doesn't interfere destructively with itself. These allowed patterns correspond to the discrete energy levels we observe. The atomic spectra, the quantum jumps, standing waves explain the quantization of atomic energy levels. And that's profound. So if the medium doesn't move, and often there's no medium at all, what exactly is moving in a wave? What's actually traveling from here to there? The answer is this: a relationship, a pattern, an organization of energy, a correlation between what's happening here and what will happen there a moment later. Consider dominoes falling in sequence. Each domino only tips over in place. It doesn't travel. It stands, then it falls, then it lies still. But the pattern of falling propagates down the line. If you filmed it and looked at any single domino, you'd see it was stationary, then falling, then stationary again. But zoom out, look at the whole line, and there's clearly something traveling. The cascade itself, the organized sequence of events. Waves are like that. They're cascades of correlated motion. At each point in space, something oscillates. Water rises and falls. Air compresses and rarefies. The electromagnetic field strengthens and weakens. But those oscillations are timed in just such a way that they create a moving pattern, a traveling disturbance. Even though nothing at any individual point is traveling, the speed of a wave depends on the properties of the medium, on how quickly one part can influence the next. In water, surface tension and gravity determine wave speed. Deep water waves travel faster than shallow water waves. Long wavelength waves travel faster than short wavelength waves. In air, the compressibility and density of the gas determine sound speed. Sound travels faster in helium than in air because helium is less dense. Faster in warm air than cold air because the molecules are moving faster. In empty space, the fundamental constants of electricity and magnetism, the permittivity and permeability of free space, determine light speed. The speed of light isn't arbitrary. It's set by the properties of the electromagnetic field itself. The true nature of waves becomes undeniable when they interfere, when they overlap. When two waves pass through the same region, they don't collide like particles. They don't bounce off each other. They combine. Where both waves create upward motion, the result is amplified. Constructive interference. The peak is higher than either wave alone. Where one creates upward motion and the other downward, they cancel. Destructive interference. The water is flat even though two waves are passing through. This is interference, and it's the signature behavior of all waves. Particles can't do this. Two particles can't occupy the same space and cancel each other out. Two bullets fired at the same spot don't disappear. They collide. But waves can interfere because waves aren't things. They're patterns of motion, and patterns can add and subtract. Shine light through two narrow slits close together, and on a screen behind the slits, you don't see two bright spots. You see an interference pattern, alternating bright and dark bands. This isn't two beams of light colliding. It's one pattern interfering with itself. Light waves from both slits spread out, overlap, combine. Where they're in phase, where the peaks align, you get brightness. Where they're out of phase, where a peak meets a trough, you get darkness. And here's where it gets truly bizarre, truly quantum. Even single photons create this pattern, one detection at a time, building up the interference over many trials. The photon doesn't split. It doesn't go through both slits as a particle, but the quantum wave function, the probability wave describing where the photon might be, propagates through both slits. It interferes with itself and creates a pattern that determines where the photon is likely to be detected. This is perhaps the deepest mystery in physics, and it all stems from understanding what waves really are. Not things traveling, but patterns of possibility propagating through fields, probability amplitudes that combine according to quantum rules. I don't fully understand this. I don't think anyone does. We have the mathematics. We can calculate interference patterns to extraordinary precision. But what's really happening when a photon interferes with itself? I don't know, and that bothers me. Waves don't move, not in the way our intuition suggests, not the way the word makes it sound. What moves is organization, pattern, correlation, relationship, information. The medium oscillates in place, or the field fluctuates, or the probability amplitude varies. But the substance of the universe doesn't flow with the wave. Only the information does. Only the pattern does. Only the organization does. And this seemingly abstract distinction has profound implications. It explains why light doesn't need a medium, because the electromagnetic field is the medium, and it's everywhere already. It explains quantum interference, because wave functions are patterns of probability, and patterns can interfere even when particles can. It explains why sound can't propagate through vacuum, but light can. Sound needs matter to oscillate. Light needs only the field, which exists even in empty space. It explains why you can't surf forever on the same ocean wave, because the water isn't actually going anywhere. It's just oscillating. The wave pattern passes through, but the water stays mostly in place. The next time you see ripples spreading on a pond, or hear sound crossing a room, or watch light from a distant star, remember what you're really witnessing. Nothing is traveling in the way you think. You're witnessing something more subtle, more beautiful, the propagation of order, the movement of pure pattern through space, the unfolding of correlation in time. The wave you see is real. The motion is real. I'm not saying it's an illusion in the sense that it doesn't exist, but it's not the motion of stuff from here to there. It's not water flowing or air flowing or light substance flowing. It's the motion of a relationship, unfolding in time, connecting one moment to the next in a cascade of correlated change. Waves don't move in the way objects move. They don't travel from point A to point B carrying substance. They happen. They emerge. They propagate as patterns in fields or media that are already everywhere. And maybe that's a more profound kind of motion. A motion of information, of organization, of meaning itself traveling through the universe. This is the legacy of Richard Feynman, looking at the mathematics, looking at what we can measure and calculate, and daring to ask what it actually means. What's really happening beneath the equations? Not accepting the easy answer, not being satisfied with the description, always pushing deeper, always asking what it is, not just how it behaves. Waves don't move, they happen, and the universe is richer for it.